Hello Spark fans and welcome back to Advancing Spark, where I'm digging further into Delta Live tables today. Now last week I promised you a dynamic Delta Live table notebook, one that we can reuse to load different tables but take the same approach, the same set of transformations, the same string of different stuff going on inside of it. And that's what we're going to do today. Now, if you've not looked at Delta Live tables before, I would advise you to go back, watch those other videos, make sure you understand the concept around the functions, around expectations, all of that stuff, because I'm not going to cover it again. So go check that out, and then I'll show you how we can start to build up some generic template Delta Live table notebooks. That's the plan. If you're new around here, as always, don't forget to like and subscribe, and let me know down in the comments what you think in terms of how useful is this? Is this a pattern that you see using a lot? Now, throughout this, I've been in my own head, challenging myself going, is this something people are going to do? Because one of the whole points of Delta Live tables is to make it really easy to actually just put a load of logic, say, this is my business transformation logic, now do all the data engineering stuff for me. So if we start abstracting it and turning it into more generic frameworky stuff, does that even make sense for what they're trying to do? I don't know, but I thought I would have a go and do it anyway. So let's have a look at what we're trying to achieve. All right. Okay, so I've got a Delta Live table pipeline set up here. So you can say I'm in load generic pipeline. I've got a table called DLT product. You can see that's just adventure worky producty data. And then if we dig into that flow, we can see we've got some expectations around the size, around the valid price on that particular data set. Now, the thing I'm trying to get it to do properly is so I can go into here and then say, actually take all the same config, but instead of doing product, just go and load address. Just make it generic so we can have it parameter driven. And that's going to change the name of the table. It's going to change the actual data that's loaded. It's going to change the schema of the data set that's loaded. And it's going to change, if we dive in here, the expectations that are applied. We're no longer doing valid size, valid product. We're now looking at valid address. And that's all nice and dynamic. So that is what I was trying to get working. Pretty happy to say it's working. And we're going to take a step back and say, right, starting first principle, starting from one of the sample workbooks that's available on the Delta Live tables documentation, how do we start to get to something like that? So here's what I made earlier. Let's take a step back and see how this works in practice. Okay, so this will be more familiar. So this is our Delta Live table notebook. This is the one from the Delta Live tables documentation. All I've done is just pulled out the path to make it a little bit easier to do. And we can start to pull this apart. So there's a few things in here that we need to challenge to say, how do we make this actually dynamic? So what bits do we need? So one, the name of the table. So by default, the table, the data set name comes from the name of this function. So clickstream raw, if you're doing this, we'd see clickstream raw, we'd see clickstream prepared, and we'd see top Spark referrers would be our data set names. So when I'm in Delta Live tables, that's what I'd see. I'd see clickstream raw as that table name. But that's the name of a function. That's not dynamic. So we need to figure out how we make table names dynamic. Our expectations are hard-coded here, so we need to figure out how we actually get those to be parameter driven. We've got so these data frames that are baked into the functions, and think, how do we actually make those properly dynamic? Because we can do a bit here, but trying to do a lot of dynamic stuff inside a return statement is going to get really unwieldy and messy. How do we test this? Yeah, lots of questions, lots of things that we need to start with. So I'm gonna start slightly easily. Let's just simplify this problem. Let's get rid of our multiple tables. I'm just gonna do one table example so we can get something working. I'm gonna slap in those expectations. So that's a little starting point, right? We're gonna say, can we take this real simple example saying I'm taking my path, well, we'll change that to go from the folders I've got so I can do products, addresses, all that stuff. Take that table function, make it more dynamic. Take our expectations, make them dynamic. Figure out a way to do the data frame better. Lots of things to do. Okay, so where do we start? Firstly, we're just going to switch this over. Going to make that a little bit easier. So in my lake, in DB Lake, I've got a raw, and I've got all these different folders. So sales IT, address, product category, just a quick scrape of adventure works that we can have a play with. So first things first, I'm going to change this out. So instead of JSON path, I want to have a data path that is an F string. I'm going to put in something that it's expecting. So input data, we just make that input data as address. So then I'm going to jam that input data into that string, and that's going to be where I want to get my data from. We can start with that. But so normally if I was developing this, I'd want to be running it and testing it and making sure that works, but I can't because all of this expects DLT. So I'm actually going to strip some of this out and take that whole thing and make that a separate cell. And then I can just quickly test this, make sure this is actually, working. So if I just do that data path at the end, is that going to the right place? Is it going to show me what I want? Cool. So it's taken my data, it's injected it into the thing, standard stuff. Okay, right. So how do we then start to do some of this other piece? So at the end of the last video, when I was looking at SQL stuff, I actually went and did some of this. So what I'm going to do is I'm going to change my expectations around. So I want this to be expect all. I'm going to get rid of that. And then the expectations I've got for address, let me just grab that out. Okay, let's have that as address. I've actually got, what I've done is I've set up a quick thing so I can reference it. There we go. Well, we'll come and talk about that in a second. So I want to talk about my expectations. So that's going to be a bit of JSON that we can then put in. That address, city's not null. And then that expect all, rather than having one single thing in there, I can say, well, that's now coming from my expectations. So there's different bits and pieces we can do to start augmenting that Delta live table definition, to start plugging in some parameterized bits the kind of same way we'd normally do. So just saying, I've got a bit of JSON up there, plonk it in as that expect all, and that's then just part of that structure. Okay, I'm getting there. And then actually let's just test this. So before I actually do any of this, one of the most useful things I found is I was actually having a look at this, how this builds, and I was like, well, that's just trying to return a data frame object, right? So actually, could we do something like this? And then just trying to explore inside our data frame object doing that. Now plugging that into a Delta live table pipeline, you can run that. That works exactly the same. There's no difference doing that. So what that means is we can actually make it even more separated. So we can say, well, actually that data frame object doesn't even need to be part of that function. I can do it up here. So as long as somewhere in the notebook, before it gets to your Delta live table definition, you're creating that Delta data frame object that we're going to pass in to that function, we can do that. So actually, if we just switch this around so it works. So it's going to be sparked up. We'll go CSV. It needs to go from that path. I've hammered all the variables around. That's going to be a bit rubbish from a CSV point of view. You know, we've got no columns or anything, so we're going to do the option. I'm going to put headers in there. I want it to be really good, so I want to infer the schema as well. Okay, I'm going to make that true. And then we'll have a look at that data frame that comes back, and we can say, what's that going to be? Does that seem right? Yeah, I'm happy that that now makes sense. You know, so we can do normal stuff. We can make that a bit easier to read. Anything that you normally do when building a data frame, go nuts. You can actually just follow any kind of conventions you want. But the biggest part for me is we can test it. We can say df.display. Don't know why I put a 0 in there. If you know. There we go. So I can actually go and look at my data. I can make sure that's all working before I pass it into my Delta live table definition. So just being able to abstract that data frame out, they figure all that out up top, it means we can suddenly be a lot more, we just follow all the conventions that we normally do, right? So if I normally passed my data frame to a function that then decorated that data frame with audit date and load date and some general metadata, I can do that. I can do whatever I want with that data frame and then pass it in to this return function. Now, big word of warning. Here, I'm currently just working with data frames that are going from source data and using the traditional Spark readers. Once you get onto past your raw layer, past your bronze layer, and you're talking about silver, gold, all that stuff, and it's querying existing Delta live tables, then you don't use spark.read, use dlt.read. And that's different, and that means we can't run it as a standalone thing, and that means we need to plug it in slightly more. But even so, we can actually still run functions on that Delta live table. We can still do other things with it. So we can build reusable functions. It's not as easy to test because we can't just run it in a notebook, but you can still, all these principles still apply, right? Okay, so we're getting somewhere. So saying, give it my address. That's going to work out the input data. It's going to figure out some expectations. And actually, we can make this a lot better because I wouldn't normally do that, honestly. What I would normally do is something a bit more like this. So if we go for, what do you want? So all of my options, I'm going to say my options is same thing as we're using the expectations. And then I can do spark.options and unpack that. So it's going to pass this in. And then part of the data frame is going to take that, because I've got the double asterisks in there, to take its map, well, a list of keyword arguments, and pass each one in as a separate option. Nice, easy, suddenly a lot more dynamic. Okay, now, so far this is all hard-coded. I just rearranged some code. I've just shifted things around on the screen. So let's make that a little bit more dynamic. So I've taken those two options, product and address, and I made a super quick Delta table. So config.sources, it's got the table name, it's got that option string and the expectation string. It's just taking those two, slapping them in as text. I've been a bit lazy and just put it into string. So you'll see we've got our product going in with its own set of options and its own set of expectations. And then I've got address going in, again, with its options and expectations. So we'll see something like this. So we'll see two different sets. So we can say, I want to see my address and get those options. I want to see my product and get those options. And that could be calling a separate config database. It could be a SQL DB. It could be Cosmos DB. It could be inspecting some JSON sitting next to the file. I don't care. Put your metadata wherever you want. But just, we can abstract that out. So then just do a quick, here's one I made earlier. We can actually get rid of that now. So we don't want those two. And just replace that with, so I'm going to do another quick data frame. That's a spark.table. So it's taking from our config.sources delta table. I'm filtering it just to the table name that I'm currently on, so it's going to filter this to address. Then doing a first. That just takes the first row in the data frame, returns it as a collect up into the driver, and then I can just directly pull out the read options and expectations and pack it as JSON. It's a long-winded way of saying we can actually go and get the same thing. Oh, I need to import JSON. Let's just do that. Okay. So now we can go and get in that's our column settings, that's our expectations. Let's just test it by switching back over to product. I mean, and that's all just standard data frame stuff. That's what we do in any engineering framework that is not Delta Live Table specific, but I've just quickly hooked up the kind of ways I would normally work to this. So then I can make sure that that data frame config is going into there. It's already using that data path, which is dynamic anyway. And then my expectations I've got as expect conf now. I've changed the name of it just because who likes consistency, hey? And that's gone into there. Okay, so at this point, by changing that variable, I can have this thing load different data, apply different expectations, and apply different options into the data frame that it creates. I've made that data frame a little bit more generic. But we still got some problems. So this thing is still going to be called clickstream raw. So if I try and load this multiple times, it's going to get very confused about the table it's creating. So that's not quite right. That's not quite working. Also, this is hard-coded. So I need to figure out that way of getting that parameter from the Delta Live Tables pipeline config into my notebook. So we're not fixed yet. We've got some things that we need to do. So now the first little thing that I found is that Delta table initialization has lots of options, one of which is name. So we can have it decide the name of the data set that is creating inside our pipeline based on an option rather than inferring it from the function name. That then suddenly makes everything much more generic. So I can say, well, actually, I want to call this DLT and then whatever I call that, input data. And now at runtime, it's going to change what the name of that table should be. And again, I could have that as a function and pass the function in there entirely, as not as a function, as a variable, and then pass the variable in there. In this case, I've just done it straight as an F string. So that little trick suddenly makes this thing, that's what was allowing me in the quick one I showed at the start, saying is it DLT address, is it DLT product? You can kind of see in my history of things, it was doing DLT product. and then DLT address, and that changing what the that data set is called is all down to that option that you pass in. I can also make the comment, so if that's still talking about your the example one, I can make it the raw generic table. I can make that generic as well and have those variables plugged into it. So good, we are getting there. There's some stuff starting to pull together. So the final piece is figuring out how we plug in that conf. So let's just jump over to a Delta Live table. We create a pipeline. I'm going to call it my quick test pipeline to show you how this works. That was sitting over in here. It was in my initial config. And what I need to do is add configuration. Now this is going to add a key value pair into a little sub node of the JSON settings called configuration. And I can pass whatever I want. And what this does is it populates a session scoped variable. Well, actually, I think it might even be a global variable. So in this case, I've got this one called advancing DLT pipeline.entity_name. So then in my code, I go to spark.config and I get a bit of the Spark config. I'll be able to query this particular value. So again, call that whatever the hell you want. So in this case, I can say, well, this is address. And then when I'm in my notebook and I say, well, what's the current value of advancing DLT pipeline entity name, it'll return address, and I can use that as a variable. So that's how we need to do it. If we then create that, we can have a look in settings and we'll see where it's created there. So you've got that little configuration piece is automatically added from that initial GUI, or you can just add it in by editing this JSON here. And that's what I was doing in my example. I was going in and changing that around and going, well, actually that should be product, and allowing us to flip between it. So I'll show you how we actually access that. We go back to my notebook. Just want to go back to my notebook. Okay. So we can switch this around. So as a quick thing, what we've got is spark.config.get, and then we can talk about that entity name. So we can now say my input data is not hard-coded, but instead it comes from that particular config value. So for the Delta Live table, that'll work. For testing it here, it'll go, that doesn't exist. What is that? So we can do, what I did was a quick little try catch around it, just to make it try and get that value. If you don't have that value, set it to a default, and then initialize that variable. Now that does mean if I rerun it several times, it'll still think it's set. Details. What that does mean is we can just try this out and say I'm expecting it to be an address. So then if we print out that data path, we'll see that's now going to address. If I run my little metadata catch, you can see it's talking about valid addresses, talking about city. So when it then actually goes and gets the data frame and figures out what it's doing, it's still talking about address. And then when I actually run the Delta Live table, it'll load my DLT address as my data set and then apply my valid expectations accordingly. And that's it. That's the secret sauce for making it parameterized. It's being able to get at a particular spark.config environment variable that you are setting at the pipeline level that then is assumed to exist within your notebook. By that point, let's switch over to the one I made earlier, which I think is going to look very, very similar. So the one I was running right at the start is this one. So you can see it is doing that same stuff at the start. It's getting my config variable back. It's setting my data path by just jamming the table name into an F string. It's showing me where I'm going to load. I'm going to load from product in this case. It's going through, again, getting my metadata, getting my expectations, getting my data frame options, doing that same thing of passing it in to my data frame. So I'm constructing the data frame I want to use. And then I'm throwing it into there. You can see I've got my comment nicely formatted. I've got my table name working, and that's running. So then if we have a look at what's actually happening in this one that I showed at the start. So big thing, one, a pipeline goes to a single storage. So the location where it's going to save this data is not dynamic. So I'm not suggesting that you have a single Delta Live table pipeline and you just go and edit the settings to change the variable. You would still need to have a different Delta Live table pipeline and just change. For that one, I'm going to put in that config variable as address. For this one as customer, for this one as product. And then I'm not having to write lots of different notebooks. I'm just having to add the orchestrator over the top, pointing at each one of those different ones. So It's not entirely generic. It's templating rather than making it entirely generic. And in this case, I'm passing through the entertainment's address, and we saw that working through. See the cluster info we've got, and we can see that it's pointing out that just generic notebook that it's working with. So in that case, let's just double check. This one was running with products as the location, but it's using address as the variable. So that's why when we see it, when we run it, we hit start, in the graph, we'll see DLT address appear as the data set that we're loading. So we've got DLT address. It's got that schema because that's what's being passed into that config variable. Then if we look down at the bottom, we'll see it's completed that flow, and that's where we've got the expectation. And again, that expectation was grabbed from metadata based on the name of the table I was giving it. We can go in and say, actually, no, I don't need to do that anymore. Switch back to product, hit go, start the pipeline. And again, I can only do this quick restart of the pipeline because I'm in development mode. Be aware, if you switch it to production, it's going to automatically schedule the updating of your pipeline, but it's not going to keep your cluster alive after you've ran it. So be a little careful when you're doing that. You can see it switched over. We're now doing DLT product because the name of the dataset is dynamic because we're using that name option in the table decorator. And we can see down at the bottom on the flow progress, we've got our product-based expectations. Okay, so pretty cool. That is how we managed to make our Delta Live Table notebooks dynamic. And there's a few things to remember in there. You've got bringing out expectations, so you can actually just pass them in as that kind of bit of JSON structure and do it all at once. You've got remembering that you can have more options of your Delta Live Table function, so you can actually pass in things like the name and the comment and make it dynamic. You've got the fact that the data frame or the Delta Live Table, that just requires an object in the return statement, and so you can do whatever you want outside of that actual function to create it, to augment it, to automatically append certain columns, to apply filters, whatever you happen to be doing, you can actually build that out programmatically to augment it as you see fit. And as with anything, you can go and get your config from metadata, and that's just the way you've been working for a long time anyway, so that shouldn't be new or shocking. And then we can try and build some standards. We can try and automate how this works. What we can't do currently is say, take that same template, run it 20 times for this list of stuff. We would need to have 20 different Delta Live Table pipelines, each of which passed in its own separate bit of config. You can't, inside the notebook, wrap it in a for each loop. I tried, because it will try and recreate that function, and that function has a fixed name. And I'll go, no, that function already exists. What are you trying to do? So there's still some things that we can't make entirely super automated. But again, is that the point? Because given we can just write it in a bit of SQL, so many of the engineering things I've built will say, go off, find a bit of SQL, apply this bit of engineering so that we can do data quality checks, so that we can land it in the Delta format, so that we can manage the scheduling of it. And if this is doing all of that for us, the value of abstracting it out lessens slightly. So there's still lots of things that we can do, and lots of things like we want to add the same calculation to all of our tables automatically. That kind of thing, absolutely, we can template that out. But for the curated bits, for the business user rendered bits, how much value are we getting there? Don't know. Remains to be seen. And it remains to be seen how much the more they're going to add into this to make it do more and more and more as we go. Yeah, interesting. So that is all I wanted to go through. That is my crazy bit of making things generic. And, you know, it's a bit of fun. Why not? Do let me know what you think. Do let me know if you've tried to do something, if you've got even further, if you made it more generic. And yeah, let me know how you're getting on. As always, don't forget to like and subscribe. And I'll be with you next time with something else weird and wonderful. And I'll catch you then. Cheers.